So suppose we want to remove factors of the form bx squared minus a from an integral. Well, we'll just need to pull out our last trig identity, bx squared minus a. That'll become, we have to keep the constant value, we have to keep the minus a, but we can change the bx squared to become a secant squared of theta. And if we do that, then a secant squared minus a, you factor out the a, secant squared theta minus 1 becomes tangent squared of theta. All right, now we have to be a little bit more careful here. We're going to let our theta range between 0 and pi over 2, and in particular, we are assuming that the value of secant is positive. Okay, and this is fine. This is going to be valid if x is greater than or equal to the square root of a divided by b, but that's going to be assumed in our problems anyway, so that's not a big deal. Let's note that when we do the substitution, we'll get that bx squared is a secant squared of theta, so we'll have that square root of bx equals the square root of a secant of theta, no square. And then x is root a over b secant. Dx would be root a over b secant times tangent. So as usual, it'll be easier to see it all in action. So let's take a look. So for example, let's actually prove an inverse trig identity. We're going to prove that 1 over x root x squared minus 1 has an integral of inverse secant evaluated at x plus c. And as usual, for whenever we do these sorts of substitutions, we'll be assuming that x is greater than or equal to some number. Here it has to be strictly greater than because of the fact that if I plugged in a 1, I would get a 0 in the denominator. So, but anything strictly greater than 1, this is fine. So, let's take a look. If we want to do this, we have our x squared minus 1 term that we need to eliminate. So we'll let x squared minus 1, that'll become secant squared theta minus 1, and that's tangent squared of theta. So my x squared is secant squared, and x is equal to secant. And that gives me that dx is secant theta tangent theta d theta. All right, so we can put all this together. In the original, I can replace the dx with secant theta tangent theta d theta. The x gets replaced with a secant. Square root x squared minus 1 is equal to tangent squared. And as we would hope, we get lots of nice canceling. The secant cancels with the secant. Now, the tangent will cancel with the absolute value of tangent. Remember, the square root of a square is absolute value. But because of the values of theta that we're assuming, we have the nice property that this means that tangent of theta is equal to its absolute value. So as usual, that technical consideration can be ignored. And I'm left with, so I got nothing more than just the integral of 1 with respect to theta. So that's easy enough to integrate. That's theta plus c. Now what is theta? Well, we just go back up here to the substitution. where we said that x is equal to secant of theta. Well, that means that theta is the inverse secant of x. So I'll just make that replacement down here at the bottom, and actually that's what I was asked to prove. Theta is the inverse of secant, which we can write with a backwards arrow, or some people use arcsecant, or some people use a -1 exponent, although it's not actually an exponent, which is why I like the backwards arrow. In any case, that gets us secant inverse of x plus c, and that is what we were asked to prove. As we see up here, we were asked to show secant inverse x plus c. So that'll take care of that. We'll do one more problem. For this problem, we'll find the integral of y squared minus 16 divided by y with respect to y. And as usual, the problem will specify this. It's a technical concern. But we are assuming that y is greater than or equal to 4 in this problem. And that will make sure that we don't have any negatives underneath the square root messing things up for us. So we'll do our substitution. We'll let y squared minus 16. You always have to match the constant. The 16 there is what's important, because you can't change the minus 16. But we can change y squared into 16 secant squared of theta minus 16. And that would be 16 tangent squared of theta. Okay, so then that means my y squared is 16 secant squared, adding 16 to both sides of the first equation. So y is 4 secant, and dy is 4 secant tangent. So let's plug that in to the original. The square root of y squared minus 16 becomes 16 tangent of theta. We're dividing by y, which is 4 secant of theta. And then the dy is 4 secant of theta tangent of theta d theta. And I did that thing I always get on to my students for doing. I forgot to write d theta. Remember, what we're actually doing is there's a divide by a d theta here, but then it gets moved over here to the left. So, all right, we've got our d theta in the right place now, so all's good. Let's go ahead and cancel some nice things. I've got a 4 canceling with a 4. Actually, I got a secant canceling with a secant. And so I've got, I forgot to write the square when I plugged in. There was a square on the tangent here. So the square root of the square will cancel, and since everything's nice and positive, we don't have to worry about absolute values. So by my calculations, I got the square root of 16 is 4. Tangent times tangent is tangent squared of theta d theta. Now, I can integrate that, well, almost. I can integrate secant squared. So the next step is whenever you've got a bunch of tangents, take the tangent and turn it into secant squared. 4 secant squared of theta be minus a 4 d theta. And that I can integrate directly. I have, I'm integrating, so the integral sign will go away. And what do I have? 4 secant squared becomes 4 tangent of theta minus 4 theta plus c. So now I just need to go back up to my substitution and figure out what tangent and theta are. Well, tangent, I see right here that 16 tangent squared, I could take the square root of that to get 4 tangent of theta, and that's exactly the square root of y squared minus 16. And that's actually exactly what I was asked to find down here. 4 tangent squared is root y squared minus 16, so I'll write that down. Minus 4, what is theta? Go back up here. Well, I have y equals 4 secant of theta. So let's solve that. That'll get me that theta. I divide both sides by 4 and then take the inverse secant. Inverse secant of y over 4. That'll get me inverse secant of y divided by 4 plus a c. And that is back in terms of my original variable y, so I put a box around that. That is my final answer.